All right. So in terms of what acids are, all right, acids are really a subset of ionic compounds. They're unique, though, because they have the same cation every single time, and that cation is hydrogen. All right, so we can think of acids as ionic compounds where the cation is H+. All right, there are actually two major exceptions to this rule. Just one. The first major exception to this rule is water, H2O, and actually hydrogen peroxide, which is funny that Chris brought that up this morning. All right, those are the two exceptions to the rule. Basically, what I mean by that is hydrogen is not the cation in these compounds, okay? We'll actually learn a little bit more about why next week when we start talking about molecular compounds, okay? So the deal with acids is we have two types, all right? We have acids that do not contain oxygen, and then we have acids that do contain an oxygen. And the reason why acids can be a little bit complicated is because we have a set of naming rules for the acids without oxygen, and then we have another set of rules for the naming the acids with oxygen. Okay, so we're going to start by talking about the acids that don't contain oxygen. All right, I'm going to go ahead and type out our naming rules here, and then we'll go ahead and take a look at a couple of examples together. Okay, so the acid name is coming from the root of the name of the anion. Okay, we are going to add the prefix hydro and the suffix or the ending of ic, I-C. Okay, again, remind yourselves here that the cation is already spoken for. It is hydrogen. All right, so let's take a look at an example here together. And my first example is going to be HCl. Okay, so I recognize this is an acid because hydrogen is the cation, and then I see that it's bonded with chlorine. I know hydrogen has a +1 charge, chlorine has a -1 charge, and that's why I have a 1-to-1 ratio here. I'm going to start by naming this by writing the prefix hydro. Good, yes. All right, Cl is chlorine, so I want the root of that in the name. So chlor, and then I want the ending as ic, so hydrochloric acid. All right, we always end the name with the word acid. Okay, hydrochloric acid. It's, go step by step. Start with that prefix, put the root in, and then add the IC at the end. All right, let's take a look. Go down to the bottom, guys, and let's go ahead and start by identifying the acids that begin with hydro. Okay, hydro really tells us that that acid is not going to contain oxygen. All right, so let's circle the ones that begin with hydro on the name side. So we have hydrochloric acid again as number 1. I see hydrobromic acid, and I see hydrosulfuric acid. All right, on the right-hand side, let's circle the ones that don't contain oxygen. So I see number 8, there's no oxygen there. And I see number 12, there's no oxygen there. All right, so let's practice writing the formulas for 1, 5, and 7, and then let's practice writing the names for 8 and 12. All right, hydrochloric acid, we just did that one, but we'll talk through it again. I recognize that hydrogen is going to be the cation. I see chlor, so I'm thinking Cl, -1 charge. And so if I put those two together, I end up with HCl. I just need one of each of those ions. All right, hydrobromic acid, again, Hydrogen is the cation. That's always going to be the case. I see brome, so I'm thinking bromine, which is a -1 charge. So again, I just need one of each of those ions to have a neutral compound. So I end up with HBr for hydrobromic acid. Okay, hydrosulfuric. Again, hydrogen is our cation. Sulfur is S-2. So what would my formula be for hydrosulfuric acid? H2S. Exactly. I'm going to need 2 hydrogens there to balance out that S. Okay? Let's do the reverse. Let's work on 8 and 12, where we're given the formula and have to write the name. Now, CN is actually a polyatomic ion, all right, and that's cyanide. Okay, so it's a little bit weird. We're bonding our hydrogen with cyanide. So we're going to start again with our hydro prefix, hydro, and then cyanic acid. All right, so I've kind of got my prefix, I've got my suffix, and then I have the root in the center there, coming from my cyanide. All right, let's do number 12. So we've got hydrogen and iodine. So we'll start that off with hydro. I'm thinking iodine. Careful here, there's a lot of vowels. It looks a little strange when we write the name out. Hydroiodic, with my IC there at the end, and then acid. Okay, so again, we've got the prefix, we've got the suffix, and then we've got the root there. All right, friends, any questions or concerns on those 5 examples that we just went through? Everybody's okay so far? All right, let's take a look at the rules for naming acids that contain oxygen. Okay, all right, so let's write the rules out first, and then we'll take a look at this. Basically, matching up our hydrogen cation with our polyatomic ions. Okay, so if you don't have your polyatomic ion chart out just yet, make sure you have that in front of you. All right, so the acid name comes from the root name of the, I'm going to say oxyanion. Don't get confused by this. This is basically just saying the anion contains oxygen, okay, which we've already identified here anyway. All right, so it comes from the root name of the oxyanion or the central element of the oxyanion. All right, again, I will show you what I mean with a bunch of examples here. Okay. Here's the deal, guys. If you take a look at your polyatomic ions, what you recognize is that the majority of them either end in ATE or ITE. Okay, so if something ends in ATE, we're going to have a different rule for that naming than if it ends in ITE. Okay, so we really just need to look at the name of the polyatomic ion, figure out does it end in ATE or ITE, and then we'll know how to name it. Okay. So if the anion ends in ATE, you are going to change the ending to ic. All right, so let's do an example. HNO3. First thing I notice is that this definitely has oxygen in it. The next thing I'm going to do is figure out what the name of that NO3 polyatomic ion it is, and it is nitrate. Okay, it ends in ATE, so I am going to name this nitric acid. That's it. No prefix, no changing here. We're just going to change that ending to IC. That's it. All right. What about when we have the anion or the polyatomic ion ending in ITE? Okay, we are going to change the ending to OUS. Okay, let's do another example. We'll do one very similar to HNO3. Let's do HNO2. Okay, NO2 is nitrite with an ITE at the end there. Okay, so I'm going to change the ending to OUS. So nitrous acid is my name. Questions or concerns there? All right, let's go ahead and finish off the bottom chart here together so that we have a bunch of examples for you. All right, perchloric acid. So we've already kind of identified these are the ones that have oxygen, that contain oxygen. So perchloric. So the first thing that I'm thinking is I'm looking at my polyatomic ion chart and I'm saying I'm looking for something with perchlor in it. And because this ends with ic, I'm looking for maybe something that ends in 8, okay? Good, good. So it is ClO4 and it has a -1 charge, right? Did you guys all find perchlorate? It's at the very bottom of the first -1 charge column there. Okay, now what we have to think about is hydrogen is the cation still every single time. So looking at the charges here, I could say that the formula is HClO4 because I need 1 hydrogen and 1 perchlorate. All right, sulfuric acid. Again, I'm looking for something that has sulfur in it in the polyatomic ions, and I'm looking for something that ends in 8, okay? I find sulfate, SO4, yep, -2. And then I need to think about how many hydrogens I need to balance that out. I know I'm going to need 2 hydrogens there. So my formula becomes H2SO4. All right, nitric acid, we did do this one, but let's work through it anyway. I see nitric, it ends in ic. I'm looking for something with nitrate that exists. It is NO3 -1. I know that I'm bonding it with hydrogen, which is a +1. So I'm just going to need 1 of each ion, and I end up with HNO3. All right, carbonic acid. Okay, I'm looking for something with carbon, and it needs to end in ATE. I find carbonate, which is CO3 -2. Again, I'm going to need to bond it with hydrogen as the cation. Excellent. H2CO3 is my formula there. Friends, any questions or concerns so far? Everybody's okay? All right, let's take a look at the second column here where we actually have to name. All right, here's what I would advise, guys, when you're starting these off, okay, and even maybe next week on your test, you want to write down the name of the polyatomic ion, okay? So NO2, when I see that, I look at my polyatomic ion chart and I recognize that as nitrite. All right, it ends in ITE, so I'm going to change the ending to OUS. So I end up with nitrous acid. Number 10, H3PO4. So I'm looking, I find PO4. It is phosphate. Let me write that down. Okay, it ends in ATE. So I'm thinking I need to change it to ic. So phosphic acid. All right, HClO. Careful with our CLs. There's a lot of polyatomic ions with chlorine in it. ClO is a -1 charge, and it is hypochlorite. Okay, I'm going to change that ending to OUS, so I end up with hypochlorous acid. All right, H2SO3. SO3 is sulfite. All right, ITE, I-T-E, I'm going to change that to OUS. So I end up with sulfous acid. Last but not least, HClO3. ClO3, that is chlorate. 8 gets turned to ic, so I'm going to end up with chloric acid. Friends, any questions or concerns so far? Everybody okay? All right, so let's take a look at your Canvas assignment again. All right, so you are going to work on the naming acids practice 1, okay? That is the assignment, that is the worksheet that I would be working on today if I were you. And then naming ionic compounds practice, all right, I would actually, if I were you, I would save that till Sunday, because what this is basically 40 names, and you're going to write out the formulas, okay? This is meant to give you a really good preparation for your quiz on Monday, okay? Yes, go ahead, Chris. How many questions are on the quiz? There are 10 questions on the quiz. So there's 5 formulas, and you'll write the name, and then 5 names, and you'll write the formula. Okay? Does anybody want to go through any of the 40 questions here together? Would that be beneficial to anybody? Everybody's okay? Okay. All right. So